Okay, next we are thinking about the finding d, right? So one thing we know is the velocity is constant. That would mean in terms of acceleration, there's no acceleration, right? And also constant acceleration motion equations are applicable. So we are writing our position equation, and then knowing that acceleration is 0, also at the start x0 is 0, and the only term left is v0t. So what is v0? It is 5 miles per hour given in the problem, and we want to get in terms of feet, so this is miles. So we are using 5 miles per hour and multiplying that by 5280 feet per miles. Okay, so that is the conversion factor. You do not need to memorize this. If you need it, it will be given. And the other one is 15 minutes, but we have hours, so we need to be consistent. We need to convert it to hours, so we are using these two. So in this case, you can see that minutes are gonna go away. You're gonna end up with hours, and I think everyone knows there's 60 minutes in an hour, right? So this conversion factor, we don't give you this because everyone knows it. But again, if you if you're not sure about it, just let us know. We don't mind telling you what it is. So miles canceled out, minutes canceled out, and we are ending up as also hours canceled out. We only have feet left, and then we're multiplying everything, and we are getting 6,600 feet. Okay, so a couple thousands of feet as we expected. So using this work equation, plugging everything will result in almost 300,000 feet-pound, a foot-pound. And this is the work done by the horse. Again, because we use only the work done by the force of the horse, right? So this is part A. Part B is finding the power. Yeah, we estimated to be 1 horsepower because it was the cart was carried by or pulled by the 1 horse, right? So since the force is constant, we can also use this equation as we developed earlier, and the equation is f dot v. That becomes fv cosine theta. And again, we're plugging numbers in, doing some conversions to feet, and you can see that hours, but these two are the conversion factors so that we can get feet foot-pound per second. But it's very straightforward. As long as force is constant, you can use this, okay? You can use this equation. So at the end, what do we get? In horsepower, we get 0.6. So we ask this question, is it a pony? Because it's less than 1. But yeah, the horse outputting more power will get the cart moved in a shorter amount of time. So that's what power means, okay? So hopefully the power definition is more clear. Next, I ask you to skip these parts. Yeah. So it says skip to 238. So that's what we're gonna do. I kind of blocked these because again it's time sensitive. So this is another 22.12 is another quiz question. This is you gotta think about the kind of how to find power. We are looking for the most powerful one. It is related to its weight force, but you gotta think about how to figure things out. So I'm not gonna give you too much information. I want you to give it a try first, and there will be some feedback in the quizzes. So the summary part, once again, we're there. In most processes, we are more concerned with the rate of doing work. That is when you see the rate of work, that means it's the power, okay? Then the amount of work. The average power is the work done by the time interval. And the instantaneous power is the force dotted with the velocity. only when force is constant though, remember that. Otherwise it is the derivative of work done with respect to time. So keep forgetting putting check marks. For cars on the level ground, a portion of the engine's horsepower goes to overcome friction. That is rolling resistance, and we are working on rolling resistance in the project assignments. And with those assignments, this is going to be much clearer. And some of them will go into drag as well, and we will do those power calculations. And the power needed to overcome rolling resistance is proportional to V squared, and drag is V cube. We are not going to look into this, and I did skip that part because we added the project assignment. So in the example we skipped, there was an like equations were given, but you don't really understand why they're proportional to these. So that's why we switched to project assignment. But don't worry about the last statement too much. Later on, depending on your major, you will learn more about it. You may need to, okay? Not necessarily though. Okay, so this yellow box means this is the end of the chapter. Okay, so this is chapter 7. We finished it. And next time, again, the exam next Wednesday is going to focus on chapters 6 and 7. And I'm going to start chapter 8 on Friday, but that chapter 8 is really more conservation of energy, which is going to really help you. Although it's not the topics that we're going to cover in detail are not going to be necessarily in the exam, but still the procedure, the methodology that we use is still included. So I think you'll still find it useful for the exam that we will take it on Wednesday. And Monday, I'm planning to just do review. That means we are going to solve some problems related to the forces, related to some of the energy applications, and finding work done by the forces, okay? So I have a couple questions, and you did pick up a couple handouts. I think I'm going to add more to that, but I'm planning to do that. I might post some example problems, and then we can hold a live session using Zoom. Or just let me know how you're comfortable with it, but my thoughts are not finalized on the review for next Monday, okay? And again, we have an exam on Wednesday, April 1st, and it's not, I'm not fooling you, although it's the April 1st. There will be an exam on that day, and we are gonna discuss more specifics on Monday, okay? And exam is on Wednesday, next Wednesday. Okay, so hopefully you are getting used to the way I'm also kind of getting used to and feeling better about how I started doing this. I hope it wasn't too fast. I really wanted to kind of review what we have in the PDF because some of you said it takes too long. So hopefully this helps. But I would still, before listening or my videos or checking my videos for the today's class, for example, I would definitely give it a look and kind of skim through it so that before I explain things, you kind of think about it. And maybe sometimes we need to make some predictions and such, so you can do those beforehand. Okay, I would suggest that. Again, I'm always open to feedback. I'm collecting your feedback. Some of you already given me valuable feedback, but I still am. I'm hoping that you all give me some feedback. So please do so, and take care of yourself.